Right, let's give it another minute for people to join. Right, 28 right now. Hello and welcome everybody. Good morning, good evening, good afternoon, depending on where you are. Welcome to our fourth webinar of our 5 series. Let me introduce you to the panelists for today. It's Dr. Mindong Chen. He's the speaker for today, and we have Yunan Gao. He is our current ICOR president, and we've got Boei Zhang. He's the focal point of CSCP. He's helped arrange all of this to make this possible. And we've got Steve Tate, the past president for ICOR. And I'd like to invite Steve to give you an introduction to ICOR.
Okay. Welcome, everyone. This is number 4 of our webinar series in collaboration with CSCP, which is the Chinese Society of Corrosion Protection. We have been in discussions working with them closely the last 12 months and have recently signed a MOU in October to have some joint events and to collaborate going forwards. So the image you can see there is the signing of the agreement between ICO and CSCP, which took place at the International Corrosion Congress in Cheyenne. Next one, thank you. As Mei Ling, our Aberdeen chair, explained, on the 13th of November, I transferred my presidency to Dr. Yunan Gao, who is now the new president. I shall be supporting him for the next 2 years as the immediate past president, and we will both work together on the trustees of the ICOR charity. Thank you. We have quite a long history going back to 1959, so that's about 65 years. We are based in Northampton, which is about 1 hour from central London. We have 8 other UK regional branches throughout the United Kingdom. Aberdeen, Central Scotland, Manchester, Yorkshire, Northwest, Midlands, Birmingham, Swansea, London, and possibly a future one in Ireland at a later date. And we recently invigorated our Newcastle branch back in 2023. Okay, thank you. So currently we have about 1,500 members, but we're looking to increase that by about 10% over the coming year or so. We have about 150 companies supporting us, and we are currently exploring additional branches in India and the Middle East. Thank you. We have a corrosion management journal, which is a combination of technical articles and institute news, and we invite any interested party to submit possible articles for publication. Normally these have a limit of 2,500 words, but you can negotiate with our editor on the address given, editor@icor.org, if you have a specific need to expand it. Thank you. We offer different types of professional membership. The main grades are technician, member, and fellow. if you have the required experience, you can apply directly for these through our website. You can also later on apply through ICOR to become either a chartered scientist or a chartered engineer. Okay, thank you. This is the next few slides are just a few examples of some of our divisional activities. Our corrosion science division very much focuses on the academic and research side of things. So we make awards to students for the best papers, etc. And we have an annual conference. This year it was in Manchester, and the previous year it was in Bristol. Thank you. We also have a corrosion engineering division, which obviously focus on more the industrial side of things, and working also with some government research bodies such as the National Physical Laboratory that you can see in the picture there. And in the middle is one of our past presidents, Professor Gareth Hines. Thank you. And finally, our young ICOR division is intended to help people, particularly within the first 5 years of their graduation, to help them network and make contacts with industry and to progress their careers. We also run a 12-month long young engineer program, which recently concluded this week. So this year's program has just finished, and the winners will be going to next year's AMPP conference in Nashville, and also to the AMP leadership program. Thank you. And finally, we have our scholarships with the University of Manchester, where we support both undergraduate and postgraduate students through their studies in corrosion to encourage them to become involved in the corrosion prevention industry. Thank you. And as I mentioned before, we have the 2 grades of chartership that you can apply now through ICOR to progress to that qualification. I think that's me. Thank you very much.
Right, thank you, Steve. Right, up next, it's Boe. He'll be giving you an introduction to CSCP.
Hi, good afternoon and good evening, everyone. I'm Boe Zhang from CSCP. Maybe today there are not many participants from China because it's the Friday night. So I'll give a brief introduction of CSCP. Chinese Society for Corrosion and Protection is a member of China Association for Science and Technology, and it was founded in November of 1979, and we have over 8,000 individual members and over 280 group members. And also we have 7 working committees and 25 specialized committees in different fields of corrosion and protection. And also we have branches located in Beijing, Shanghai, and 15 other provinces and cities. And this is the board member of CSCP. The president, Professor Xiaogang Li, is also the director of National Materials Corrosion and Protection Data Center in USTB, University of Science and Technology, Beijing. And also Professor Chen Jueqin now is the Secretary General of CSCP. And we have 10 vice presidents. They are now working in different institutes and universities in China for different fields of corrosion and protection. And what we do are mainly focusing on the 5 aspects. And the first is for the academic communications, including holding the corrosion protection conferences, the domestic ones and international ones. And also we have we do some science popularizations. And we have our own journal and magazine, and also we do some popularization during the Corrosion Awareness Day. And we also provide the industry service to the oil and gas and some offshore engineering. And we provide them some training and education, certification, and consulting. And CSCP also can issue the group standards and also the awards for corrosion protection. And also we have very close international relations with different associations and institutes around the world. And for the international collaborations, CSCP is a member of International Council, Corrosion Council, and World Corrosion Organization. And it is also a co-founder of Asian Pacific Materials and Corrosion Association. And we have established bilateral cooperation with the organizations from 18 countries around the world, like the US, the UK, France, Germany, and Singapore, Thailand, and so on. And with the WCO and the EFC, we gave corrosion awareness honor to this to the renowned scientists. And also we have the Young Scientist Grant together with WCO, EFC, and AMPP. Since we have a very huge industry market like the oil and gas and offshore engineering, we have we have many different training and certification programs, and we do some NACE now AMPP training, like we are familiar with the CP1 to CP4 different courses, and also we have our own training and certification. And now from 2006, we have over 60 courses and more than 1,200 trainees. Yeah, during the past 3 consecutive years, we have held 3 international conferences in China. And in 2022, we held an International Congress on Materials Degradation and Protection, which is like a webinar. And last year in 2023, in November, we had the 19th Asia Pacific Corrosion Control Conference. It was held in Guangzhou, and many scientists like Philip Marcus, Terry Herman, Nick Berbedis, they have, and also the professors from University of Manchester, they came for this conference. And just last month in October, we held the 22nd International Corrosion Congress in Xi'an, and President Stephen and Yunnan came to join us. I think over 1,200 participants joined us for this big event. Oh, that's all for the introduction of CSCP, and you can refer to the official website and the official group chat account for more information about us. Thank you.
All right, thank you, Boy. And as usual, before we begin our presentation, I would like to note that this session is being recorded. And if you've got any questions, please enter them in the Q&A box, and we'll address that at the end of the presentation. And we've got many CPD requests, So say it will be sent out after we conclude the 5th presentation. You can expect that in a week's time. And for our presenter today, it's Dr. Mindong Chen. Dr. Mindong Chen is an Associate Research Fellow in the Department of Equipment Safety at the Sinopec Research Institute of Safety Engineering in Qingdao, China. Dr. Chen is engaged in technical R&D in the field of equipment safety at the Sinopec Research Institute and of Safety Engineering and the National Institute of Hazardous Chemical Safety in Qingdao. His primary research areas include materials corrosion and protection, equipment conditioning, monitoring, and equipment integrity management. He has published over 20 SCI papers, including 2 ESI hot papers, and holds more than 30 patents. Dr. Chen serves as a reviewer for several international journals and has led projects funded by the National Key R&D Program of China, Sinopec Corporation, and the National Natural Science Foundation of China. His achievements include the following awards: first prize in Science and Technology Progress from the Chinese Society for Corrosion and Protection, second prize in Management and Technological Innovation from the China Association of Plant Engineering, third prize in Technological Invention from Sinopec Corporation, and the second prize in Management Innovation from Sinopec Corporation. Please join me to welcome Dr. Chen.
Okay, thank you very much. Thanks very much for the invitation of Institute of Corrosion UK and Chinese Society for Corrosion and Protection. I am very pleased to be able to share my work here. The title of my report is Optimizing Corrosion Resistance of Low alloy steel for the petrochemical industry by corrosion big data methods. I'm Mindong Chen from Sinopec Research Institute of Safety Engineering in a very beautiful city of East China, Qingdao. My report have 3 parts. The first part is the research background. First of all, let me briefly introduce the institute I work for. Research Institute of Safety Engineering is one of the 8 research institutes directly under Sinopec Group. Sinopec Group ranks 5th on the Fortune Global 500 list in 2024. Our institute have 3 parks. Besides, we have one medium-size engineering experiment and test site, and one field exploration test site, mostly in the coastal city of Qingdao. Our research mainly includes process safety, equipment safety, environmental protection, risk assessment, risk monitoring, and early warning, material failure analysis, safety and environmental protection, new technologies, and also we are the National Key Laboratory of Chemical Safety. We have 3 national laboratories in total, and we have 8 provincial and ministerial key laboratories, including chemical safety risk warning and intelligent management and control technology. Our institute have a total number of 700 people with 18% PhDs and 51% masters. The picture that are at the bottom right is a photo of the field test site where destructive experiments can be can be conducted. About myself, I graduated from University of Science and Technology Beijing in 2018. My advisor is Professor Li Xiaogang. From 2018 to now present, I'm working in Sinopec Research Institute of Safety Engineering. During the 2020 and 2021, I had a temporary position in a refining and chemical enterprise. I have responsible for research projects funded by National Natural Science Foundation of China, National Key Research and Development Plan, Scientists and Technology Department of Sinopec Group, Petrochemical Safety Administration of Sinopec Group. I'm responsible for the big data monitoring technology of chemical process corrosion, realized accurate perception of hidden process flow and equipment damage through multi-dimensional and multi-modular data modeling and deep learning of equipment material and current potential. This work have gained the first prize of the scientific and technological process of Chinese Society for Korean and Protective Society. I have responsible for the dynamic monitoring and early warning model of major hazard safety production risk based on event tree, protect layer, and Bayesian method, and applied to the National Hazard Chemical Safety Risk Monitoring and Early Warning System. And I have responsible for the research and development of equipment status intelligent monitoring and preventive maintenance technology, especially established the typical characteristics of dynamic and static equipment failures, and realized the online monitoring and early warning of typical equipment. First of all, I would like to introduce the background of the study. In China, refining industry mainly processes crude oil, which guarantees China's energy supply, but also brings severe corrosion problems to low-alloy steel. The refining industry demands materials with high corrosion resistance to withstand harsh conditions. Recent years, we have done a lot of research around this need, include improve the corrosion resistance of low-alloy steels used in petrochemical equipment by optimizing alloy composition, minimize the equipment failure risks due to corrosion, ensuring long-term operation and harsh conditions, reduce maintenance costs and environmental impacts associated with frequent equipment replacement. Chinese refiners make crude oil from all around the world, and because of the different corrosive substance in the composition of the crude oil, sometimes very serious corrosion problems can occur in a very short time. The picture here shows the corrosion of the enterprise's pipeline, pipes and heat exchange. Now I will Professor Li Xiaogang of the University of Science and Technology Beijing has proposed the idea of corrupting big data, Korean big data, and has reported on numerous occasions. Influenced by this, we also adopted the concept of Korean big data for research. Professor Li Xiaogang's concept of Korean big data has opened a new pathway for research in Korean science by collecting and analyzing large data sets related to Korean. Researchers can gain deep insight into Korean behaviors and predict material performance and specific environmental conditions. This approach has found applications in material design, Korean monitoring, and the development of protection strategies. And we are also working on it with reference from MPJ materials degradation. Model the effect of allowing elements on Korean resistance and environmental interactions. Use machine learning to analyze large data sets from experiments and simulations, predict alloy properties, and optimize the compositions. We are inspired by this reference. In our work, we have also proposed and established new theories, obtained interesting conclusions, and verified the accuracy through the practice. The second part, I will show you two case study. Now let me share the first one. The first problem is the Korean problem in the application of low alloy steel in offshore petroleum engineering with high chloride iron content and periodically changes in environmental factors. We have developed IoT devices that can capture the open circuit potential of 50 materials at a high frequency with high measurement accuracy. The alloy elements composition of these metals sheets is this, and each metal sheet have 3 parallel samples. Here are the open circuit potentials of 14 materials that we collected in the real environment. This graph in the left shows the open circuit potential, and the test of open circuit potential in the environment has been carried out for a long time, but with the improvement of technology, high frequency, long period, and multi-channeled online testing has been realized. This also provides a basis for us to use this data to carry out follow-up work. At the same time, we also have the data of cyclical environmental factors so that we can analyze the internal relationship between the two data. and we analyzed the fluctuation characteristics of the measured results and established an evaluation index of corrosion resistance. This index is different from the corrosion rate, but it can also reflect a certain corrosion resistance factor in the corrosion process. When potential fluctuations occurs, the reaction equilibrium of the metal in the environment shifts. This means that the protective rust layer of the oxide layer on the metal surface has a reduced hindrance effect on diffusion, causing the ionization equilibrium of the metal to change with the environment variations. Therefore, when the metal surface is covered with a stable rust, layer, significant fluctuations in the corrosion potential in response to environmental changes indicate that the rust layer's diffusion inhibition is poor, resulting in low protective performance in the given environment. So we defined the PFI indicator as the inverse of the standard deviation of the open circuit potential fluctuation resulting from the environmental changes. In this regard, we carried out verification work. We use the Fourier transform. The Fourier transform is applied to the data of a long period open circuit potential monitoring and the periodic change of environment. It is found that the peak value of the transform has a good consistency. The screwed part of the graph on the left is the result of long period trends. The characteristics peaks after Fourier transform also verify that this fluctuation is caused by the periodic change in the environment factors. In order to extract the effective characteristics peak data, we smooth and filter the results of the open circuit potential measurement and obtain the trend term. Then the fluctuation term is obtained by subtracting the trend term from the open circuit potential monitoring data. The figure on the right is the result of the decomposition. We have tested many filtering algorithms and found that Hodrick-Prescott filter has been the best effect on the extraction of the open circuit potential fluctuations, which are caused by the corrosion environment fluctuations. For the decomposed trend term and the fluctuation term, we also do the Fourier transform to evaluate the filtering effect. The two graphs on the left are the transformation results of the trends. and the two graphs on the right are the transformation results of the fluctuations. From the result, the amplitude of the Chen term has been completely eliminated, and the PSD feature appears as a straight line in the exponential coordinate system. The Fourier transform results of the wave term still return several characteristics peaks, which are consistent with character peaks of the environmental changes. And the PSD indicators are the concentration. The PSD indicators are concentrated in the frequency range of 0.01 to 0.1, which is consistent with the frequency of environmental change. These results illustrate the effectiveness of data processing through the Hodrick-Prescott filter. And in big data analysis, in the calculation process of removing removing the factors and extracting effective factors, it is very important to return effective information as much as possible, realize the place of noise and return more relevant information. The two graphs on the left are the PFI indicators that calculated by the extracting the fluctuation terms. The two graphs on the right are the correlation value obtained by Spearman and MIC correlation analysis between PFI indexes and alloying elements in different time periods. It can be seen that these results are very consistent with empirical cognition, and some new rules are found in the we can find in the chart. These new laws can guide us to make some new attempts in the design of material alloy elements. All the data we used were obtained from actual environmental tests, and there were many correlations value as high as 0.7 in the results, which is already a very high correlation conclusion in the engineering field. Here are some algorithms used in the previous procedures. In the course of the study, we test many kinds of algorithms, and these are verified by us to be more effective in this study. As a result, some elements exhibit a strong linear correlation with PFR. Aside from linear relationship, no significant nonlinear correlations are observed based on MSC. In the result, in the 120 hours to 500 hours interval. Iron content shows a negative correlation with PFR, and nickel, chromium, molybdenum, and the phosphorus shows positive correlation with PFR. In the 1,500 hours hour to 2,500 hour interval, we can also get some conclusion. This result is consistent with many of our traditional understanding, but also found some new results. We collected the rules obtained from at different time intervals and found that these elements with low correlation, such as the diagram on the left, did not achieve 50% correlation, while the elements that could provide great corrosion resistance or reduce the corrosion resistance had over 50% of correlation. More information can be found in this reference below. Further, we also tried the concept of the AI for sense, investigate how the correlation between PFR and alloy elements evolves over time to understand long-term material performance. Compared analytical results with empirical knowledge to confirm the validity of findings. Use independent experimental data to cross-check the conclusions and translate findings into actionable insights for optimizing alloy composition for offshore IO construction. Focus on improving corrosion resistance and specific marine environment conditions, develop predictive models for forecast PFR based on alloy composition and environmental factors. Use these models to design new metal materials with enhanced corrosion resistance for offshore applications. So we use the AI for science methods. We set up the CIV-RVR artificial neural network model. The picture on the right is the steps. This is our evaluation criteria. And you can see on the right, that we obtained very good results. We also further through artificial neural networks, many of corrosion resistance model of key alloying elements. And we established the steps. First step, we built the function in 22 dimensions. And step 2, we calculate the average vacuum from the initial stage to the stable stage. Step 3, visualize the relationship between vacuum and any 3 XNK. Step 4, 3 grids are obtained using k-means. And step 4, the alloy element composition interval is used to judge the corrosion resistance. Now let me introduce the second case. is for the petrochemical plant. Low alloy steel material used extensively in refining and chemical plants. Different sources of imported crude oil, equipment material series corrodes. Here is the basic information about the material that we test, and all materials under the same use standards. These are the potential dynamic polarization, Raman and rust cross-section test results. And we also do the alpha divided by gamma index by the Raman experiment. And we also do the we have done the electrochemical impedance and fitting, and we get the index of the RF and RCT. The experiments on the 3 slides above were all obtained in the laboratory. On the petrochemical plant, we developed an 8-channel array electrode probes, and the probe passed pressure and safety test, so they can be used in the petrochemical plant. This is a probe that, for the field applications, multi-channeled and single-channeled. A 2-electrode system of metal insulting materials reference electrode is used. So the relative potential and the electrochemical impedance can be measured. We also established the application method in real plant, and the diagram on the right shows the test result. According to the characteristics of materials and the environment, we established the method of obtaining alcohol. This is same as we mentioned previously, that the principles for establishing corrosion resistance indicators. We calculate the PFR and ACRO. The ACRO, we use the method in the red to based on the Stern based on some reference. And after we get the quantitative data, we build the database and the digital twin space to dig out the correlation and law. These are the quantitative indicators and the digital twin data. And we can also find some high correlation relationship between the index and the law elements. So these are also the results. Further, we have established a set of rules to extend the DCS and LIMS data to the database. Based on this data, we conducted a study on predictive modeling and quantitative relationship modeling, which is a comparison between the periodic curve we obtained and the actual measured values on the left, on the right. As can be seen from the MAPE number, we also obtained very good conclusions. Based on this work, we finished the macro-aligning composition design and two heat treatment processes. We have completed the pipeline manufacturing and carried out industrial tests in May 2023. And with this study, the sulfur protection value, we have gained some the sulfur protection value of the atmospheric and vacuum equipment was effectively increased. And the test pipe section, which we designed the alloy elements, was reduced. The corrosion rate reduced by about 60%. And other conclusions are used for material selection and material design of the equipment to enhance the operating life of the equipment. This is a customized heat exchanger according to our requirements. The third part is the vision. Combined with the corrosion big data idea, we achieve materials corrosion big data monitoring and early warning, combined with real-time process data of the plant, and optimizing and development of corrosion resistance equipment materials for refining and chemical process environment based on corrosion big data to improve process marking. And we also have some vision for the future. We are looking forward to the development of AI technology and the application of AI for science. In the previous work, we have established principles for establishing corrosion resistance indicators. We hope to use AI to discover empirically correlated data on corrosion resistance evaluation indicators, find more indicators such as PFR and ACRO, and we wish to use AI select neural network models, predictive deep correlation, and quantitative relationship methods to find more quantitative relationships. And also we want to use AI makes decisions and manage recommendations for us. This is the full content of my report. Forgive my poor English. Due to the requirements of the internal management and confidential requirements of Sinopec group, some data cannot be disclosed now, but you can obtain some data in the published literature. This work is also supported by Professor Li Xiaogang and Professor Fu Dongmei's team from the University of Science and Technology Beijing. That information can be found among the co-authors of our published articles. And thanks for everyone listening, and thanks for CSCP and ECHO UK. Hope your cooperation will lead advances in the natural science and engineering. And here is my contact information. Thank you.
Right. Thank you, Dr. Chen. That was a very deep topic. So we're going to our Q&A session. We've got 3 questions from Dr. Yunan Gao. So the first question is, it has been mentioned that the imports from various resources have various corrosive substances. So his question is, are there any accepted corrosion spec or KPIs before the import can be accepted? In other words, minimum requirement.
We have an idea that when we collect the current data, we need to be real and more frequency. So that we can at the first time to find the various corrodes infect the pipelines or the equipment. We have tried our method to early warning the risk and we mainly discuss crude oil in the petrochemical plant. So so we don't have much opinion on the about KPIs before import. Okay, that's my answer.
Right, thank you. So Yunan's second question, what are the cost-saving implementation from the first case? Is it to use the low alloy steels with enhanced change chemical composition to compare against using corrosion-resistant alloys straight away?
So can you repeat the question?
Yunan, do you want to?
I think you can see the question in the chat box.
Okay, let me.
So I was asking, it's a good research project here. So apparently we dedicated to carry out some research and with an objective to get increased corrosion resistance for low carbon steel alloy, low alloy carbon steel. So my question was, compare with we use CRA, corrosion resistant alloy. See what sort of the cost benefits, cost saving implication. So I think the cost saving is the driver of the research, isn't it? If we imagine we got it constructed using titanium, we shouldn't be bothered with any corrosion at all. That would be the whole driver. See, just very in-depth, comprehensive research in comparison with using CRA material straight away. So you got a good some very high cost material, high-end material options as to be used.
You know that China is a big country for the on the petrochemical with petrochemical industries, and this also brings much risk, safety risk, and we tried to decrease the risk from the petrochemical plant, and the anti-corrosion method is very important because you know that people in the plant they don't have much time to do with many problems, so we try to decrease the situation that such as corrosion leaks and other problems. So we want to use this method to get more lifetime of the equipment, and then this both helpful for the manufacturer and and the safety. So I think the Korean science research is very important, and the also the alignment of the element optimizing is very important for the plant. Oh, okay.
Right, thanks for that. We're just going to take one more question from the audience. It's an anonymous attendee. Did you see any of the derived corrosion data did you use any of the derived corrosion data to modify or select alloys within facilities?
So can you repeat the question? Sorry.
So have you used any of the corrosion data to modify or use it for the alloys selection?
Yes, we have tried 6-meter pipelines on the tube, and the alloys just have little differences with metals before, and then also we did some design, and then performed on the plant, and the results show that it can decrease the corrosion rate
Right.
effectively. Okay.
Right. Okay, thank you. So we
Okay,
have come to
thank
the thank you, Dr. Chen. Sorry, we have overrun by 4 minutes. With that, I'm just going to end this webinar, and I'll see you guys next week for the final presentation. Right. Thank you all for attending.
Thank you very much.
Thank
Thank
you.
you.
Have a nice
you.
weekend.
Thank you.
Yeah, you too. Thank you.
Bye, everyone.
Yeah,
Bye.
Right.
it's Friday night.
Bye bye.
Bye bye. Yeah, see you
Bye.
next week.